or you can watch it easily in the YouTube. So it's successful. Okay, again we go to the file, new university program VWF. Okay, again we see edit and set end time. We set to the 116 and nanosecond. Okay, again we go to the insert node and boss, node finder, list, add the ports. Okay, and okay, we have a port here. Our input is the D and clock. You can see that input D, input clock, and D is our output. So we set here, it's 10 is okay. Clock, for example, I don't know, it's 20, for example, 30. It's up to me. Okay, and just run it. Ask me, do you want to save it? Yes, I like to save it. And this is the log. It's really very fast. I think less than 10 seconds. And this is my output for the D flip-flop. You can see this is my output, this is my input, and this is my clock, and this is my output. Okay, so it depends on your clock. And let me do another one for the, again I close everything. I close the Quartus, I close everything. I close this one as well, my paint. Okay, this is the for D flip-flop, and another one for the T flip-flop. You can see that you have a T, you have a clock, you have a Q prim here is using the R and S here, and this is the code of the T flip-flop. Let me open the T flip-flop for you. T flip-flop, I wrote it before, that's why I just opened my file. And if you check that, the name of my file is lab6tf. okay, so the name of my module is lab6tf. They are my input, output, my input, my output, and my register. And also I have a register here as well. So sometimes the register and output is the same, and sometimes the register and output is not same. Okay, and this is the condition of my always. So trigger with the positive edge of the clock, and here we assign, for example, and of this one and this one to the R. We assign it to the R. We assign this part to the S, and this one to the Q, and this one to the to the Q prim. Okay, we just run it. The compilation report is the flow summary, table of content. In the time of the compilation, I try to learn you something about this one. Here in help you can use different elements. You can find different things about the Quartus. In window you can change, you can have different window. You can see different window. It's finished, compilation was successful. And again we go to the file, new project, sorry, no, I don't like it. File, new university program VWF. Okay, again go to the edit, set end time 116 nanosecond. Actually it's up to you, but I do it because we can see that our picture will be fine. And again insert node, node finder, list, add the nodes. Okay, and okay. So we have two input. You can see the input, and they are out. For this one I'm going to like random one, and for clock I like the random one as well. It's up to me actually. It's kind of random at the random interval as well. Okay, you can see it's different. And we just the simulation. And do you like to save the simulation? Just okay, I just save it because I saved the waveform before. That's why I asked me would you like to save the change in the waveform. I said it's okay. And here you can see that this is our output. Okay, you can see this is our output based on this input and this input. Actually this input is a clock, but for the Quartus it doesn't matter, clock and input, both of them are input. Maybe in the paper you are in your mind it's different between clock and